Okay, welcome to the second half of this video on factoring sums and differences of cubes. If this seems a little disjointed, I'm sorry. I had to remake this video, so I hope it has good continuity from the first one. I think it should, but I apologize if it seems mildly disjointed for a moment. In the first video, we talked about identifying perfect cubes in constant and variable form, and how to then take cube roots and create squares. And we talked about using a chart that was kind of a little organizer because we also covered the special patterns involved for factoring sums and differences of cubes. So that chart is going to become important as well. So you'll see I'm going to use the chart to build the needed components of this answer, which is the factored form of a sum or difference of cubes. Okay, so let's take a look at the steps for doing this. And we see here that step 0 is to factor with GCF if possible. We always do this when we hear factor. We train ourselves to look for GCF as often as we can. And again, greatest common factor, gotta come first. So step 1 is create an organizer that identifies the cube root, and the square of the cube root of the given terms. That's probably easier done than said. That's where I'm going to use that chart. And then step 2 is apply the special pattern to write the factored form while using the SDP rule for signs. And again, that rule is same, different, positive. So if I had a plus sign to start, I would use the same, then different from that, and then positive to create those signs. Similarly, you'd use the SDP rule if it were a difference. So let's jump right in. I'm sure the anticipation's been killing you. So we notice here where it says factor 8x cubed plus y cubed. I see if there's a GCF, and there's not. And so then I look to make my organizational chart, which prompts me to find the cube root of 8x cubed, which is 2x. And then I'm going to square that to get 4x squared. I'll find the cube root of y cubed, which is y, and then I'll square that to get y squared. And again, this is the opportunity for me to see this is the left cubed, the left root, and the left square, as well as the right cube, the right root, and the right square. Okay? So now I just need to use my special pattern, which means I will be able to factor this into a binomial and a trinomial, and then I'll try and use the magic pen here. I'm going to start with L, which you see is 2x, followed by R, which is y, and then I'm going to move to L squared, which is 4x squared, and then I'm going to do a little mental math to do LR, which is 2x times y, which is 2xy, and then I'm going to do r squared, which in my chart you can see is y squared. Then to do the same different positive rule, I see that I have a plus, so I will do same with plus, and I'll do different from plus, which is a minus, and then the last term is just positive, whether it's a sum or difference of cubes. So if I were to multiply this binomial times this trinomial, I would see that I would get my original answer of 8x cubed plus y cubed. Okay, I'll try and go through a few of these examples. Next problem where it says factor 64a cubed minus 125y to the 12th. I ask, is there a GCF? Well, there's not for 64 and 125, and I don't see the same letter appear in both terms, so the answer is no. So I'm going to create my organizer again, and to do that, I think of this as the left cubed. I'll need the left square, and then the left root, the right cubed. I'll need the right square and the right root. And again, we said you got to go from cube to root and then back up to square when you do it. So what is the cube root of 64a cubed? That is going to be 4a, and when I square that, I'll get 16a squared. What is the cube root of 125y to the 12th? Well, that will be 5y to the fourth, and when I square that, I will get 25y to the eighth. Okay? So then again, I just need to apply my special pattern here, which prompts me to set up a blank binomial and a blank trinomial. And then it starts with L, which will be 4a, then R, which will be 5y to the fourth, followed by L squared, which is 16a squared. Then a little mental math for LR, which is going to be 20a y to the fourth, followed by R squared, which is 25y to the eighth. Okay, then I need to apply my signs of same, different, positive. I started with minus, I stay with minus, then different from minus is plus, and then the last sign is positive regardless if it is a sum or difference of cubes. Again, if I multiplied this binomial times this trinomial, I would get back the original problem. Okay? I'll do two more examples. Oh, excuse me. Sorry for that. I just need to find that example real quickly. In both of these examples, also, I'll look for GCF but won't find it. I just try and include that step because it's always good factoring practice, but I'm trying to put focus on the sum and difference of cubes pattern more so than GCF here. Okay, so this one's a little complex, so I leave that out for now. Okay, so if I ask it factor 27a cubed minus 8, I see it's a difference of cubes, and there is no GCF in step 0, so I just go to look and make my organizational chart. Okay, and the cube root of 27a cubed is going to be 3a. The square of that is 9a squared. The cube root of 8 is going to be 2. The square of that is 4. So then just using my special pattern here, okay, I'll set up a binomial times a trinomial, and then I'll just follow the pattern, and very quickly, like we said, you need to commit the memory. It's LR, L squared, LR, R squared. Just practice saying it and get it memorized. It's the way to be successful. So starting with L, I get 3a. Moving to R, I get 2. Moving to L squared, I get 9a squared. A little mental math quickly for LR, which is 3a times 2, giving me 6a. And then followed by R squared, which is going to be 4. Using the same, different, positive rule, I see the same as minus is minus. Different from minus is plus, and then P for positive, always ending in positive with these. Again, if I multiplied this binomial times this trinomial, I would in fact get back the original problem. Okay, so one last example here. Okay, factor a cubed minus 216y to the sixth, and we'll take a look at doing that. See that there's no GCF. I do again recognize that this is a difference of cubes because the exponents are multiples of 3. If you're unsure if 216 is a cube, you can go 216 cube rooted on your calculator and see that it's an integer. And in fact, I believe you get 6. So I'll quickly make my chart of L cubed L and L squared, R cubed R and R squared. Eventually you probably won't even need to write those guides. You'll probably realize it's a little bit redundant at that point. So the cube root of a cubed is a, that squared is a squared. The cube root of 216y to the 6 is 6y to the second. Again, divide your exponents by 3 when cube rooting. And then the square root of that is 36y to the fourth. Okay? The quick check for that is that your exponents should add up when going up. 1 and 2 is 3, 2 and 4 is 6, and your coefficients should multiply going up. 6 times 36 is 216, 1 times 1 is 1. Okay? So, again, loving this pattern, just going to apply it again. So I will set up a binomial times a trinomial, and then move my way through L in the chart is A, and then R is 6y squared, and L squared is A squared. A little mental math quickly for LR is going to be 6ay squared, followed by, in the end, r squared, which is 36y to the fourth. Using the same different positive rule for signs, same as minus is minus, different than minus is plus, and the last sign is always plus. Again, if I were to multiply this binomial times this trinomial, I would in fact get back the original difference of cubes binomial. Okay? So, there are the examples. Feel free to watch them over. I hope I got them right. I had to remake the video because the last time I did a video, I made a mistake or two. And then the video went funky on YouTube too, so good reason to remake it. So let's take a look here when I go to my factoring chart. Okay, my factoring chart here, just to tie up these examples and sort of pull these ideas together. When we're dealing with a sum and difference of cubes, it is special pattern factoring. Okay, that special pattern is given by L cubed R cubed being factored in the product of LR, L squared, LR, R squared, and then just keeping in mind that you do have to apply the same different positive rule for these signs. Okay. There are certain prerequisite skills that you have to have some ability around. One is identifying a perfect cube, and to do that, you need to realize the special pattern for perfect cubes. And with regard to variables, you need to realize that the exponent must be a multiple of 3. You have to be proficient in cube rooting a perfect cube, which means use the number sense you have around the constants, but for variables you just have to remember it's divide the exponent by 3. Okay? Prerequisite skill 2, you see once you get the cube root you need to square it, which is decently easy, and if you're here you should have that skill. And then multiply a binomial by a trinomial becomes important because it's going to help you check your problem. Okay? Now if I could just kind of fit these steps in. These steps are important. Okay? Sort of making space here. Okay? These steps state that we should factor with GCF if possible. That's always what we look to do in factoring. Create an organizer that identifies the cube root, and the square of the cube root with given terms. That's your L cubed, L squared, L chart, R cubed, R squared, R. And then apply this special pattern, which you will have to take some time to memorize, to write the factored form while using the SDP rule for signs. So I hope this gives you a good sense of factoring sums and differences of cubes. Once you get the pattern down, the irony I think here is this is maybe the longest combination of videos I made. Once you get the skill down, you'll be very automated at it. It's just really here understanding that we're going to go from L cubed, R cubed to LR, L squared, LR, R squared. There's a lot of skills packed in there, but once you master them, they're pretty easy. It's just piling them all together in the right order is what's important. So enjoy. I hope this was helpful, and feel free to watch it again, practice, and practice till you master it. Bye.